welcome back. What we've done in the brief interlude is obviously turn the camera around, bring the vehicle into the workshop, and I'd like to spend just a few moments just painting a picture of the environment. The environment is something that's really important for successful diagnostics. This is something we've built up over 22 years of actual specialist diagnostics experience, and care of the equipment and the environment helps successful diagnosis. We've used this preparation trolley, as we call it. It allows us a little bit of flexibility for placing tools on, such as the laptop, such as the oscilloscope, and any additional wiring diagrams, etc. we may be using. It means that we're not cluttering the engine bay up with tools and cables. It's quite important. Let's begin by discussing how to install the software. Simply insert into the CD drive, follow the prompted on-screen instructions, and after a few minutes the software will be installed in your desktop. By creating a shortcut, we can then, when appropriate, select the software, but just before that, a quick word about the connectivity. The USB lead provides the power for the oscilloscope and simply connects to one of the available USB ports in your computer, so connectivity couldn't be simpler, and also the length of lead provides enough free movement. I suggest you do use it on a trolley, but if you wished you could actually move the tool around within the vicinity of the work area, whether it be under the bonnet or actually in the cockpit of the car. So having installed the software, let's select the Pico scope, and you'll see very quickly that we will have a screen to view, and it begins with all 4 channels in auto run or free run. This means that if you simply connected your probe to a circuit, you would see some activity within that particular channel. So let's talk about the connectivity of the leads first of all. These are an industry standard BNC adapter, and these connect quite simply by a simple insertion. Line up the 2 pins and a quarter of a turn, and you have a secure BNC connection. And depending on the number of channels, inputs you want to use, continue to add the probes appropriately. There are 4 probes in the kit, so you have 1 probe per channel, plus of course inductive current probes, which we'll be using shortly. So, okay, that's the connectivity. Let's now just do some very, very simple tests on the vehicle. Let's make some very simple observations. First of all, I'm going to turn 2 of the channels off, which I'm not using. So, up on the top of the screen, you'll see a little pop-up menu which identifies channel A, B, C, and D. I'm going to select the box for channel D, and the little pop-up menu gives me a choice of changing the range, the measurement range, and also whether I wish to turn it off. And in my case I am going to turn it off. That's one gone. And likewise for channel C. And the beauty of colour is that colour separation gives you a very clear indication, very clear separation between one channel and another. It makes it much easier when you're looking at multiple inputs. So select off and engage. We now have 2 channels, A and B, active. Okay, let's take channel A and make a simple measurement. Now, as a suggestion, it makes life a little easier when you're using multiple numbers of channels. You might wish to identify each lead by colour with a bit of tape around the end. It sometimes does help. The lead itself has 2 leads in effect. Ground reference, very important. Ensure the ground reference is accurate. Where possible, I prefer to go to battery ground. If you have to go to a chassis ground, you're going to have to do some voltage drop tests to make sure the earth reference is good. So earth is very important, and of course the actual probe itself. This is the probe with which you interface in the circuit you intend to measure. And there are a whole host of probes and devices which are available. So I'm going to go and get some of those now, briefly go through them, and then we'll do some simple tests on the car. Let's take a look at some of the options of probing. Now, probing is perhaps one of the most important parts of diagnostics because poor probing leads to poor results. So it's essential that your probing is done accurately and purposefully. And due to the evolution of electronics and the way that components are now mounted on vehicles, probing is becoming more and more difficult for many reasons. Some of the sockets are sealed, some of them are discreetly arranged in conduits, etc. So we have a whole range of probes available. The acupuncture probe is one you'll use an awful lot of because this allows us to go parallel to the conductor, alongside often a rubberized weather boot right to the back of the pin. So that's one that's extremely useful. We have perhaps a tougher probe for more robust applications that has a very sharp steel pin. That would be more appropriate where you've got direct connectivity to a pin or a large component. Of course, then we have miniature crock clips where dictates, and larger crock clips. These are obviously for battery posts and large applications. And another connector which is important to mention at this point, the attenuation probe. The attenuator is used when an inductor or coil is to be measured, and this is because of the back EMF. In other words, there's a voltage spike generated when the coil is switched off. This attenuator ensures that we can see that very clearly on the screen, and within the software, which we're going to go into in a moment, it actually calls that attenuator where appropriate. So let's go and take a look. First of all, let's enter the Pico scope from the shortcut on the desktop, and alright, let's make it really simple. I mentioned the presets earlier. This means that I don't actually need to understand how the scope achieves the collection of an image and displays the image. All I need to know is how to go to the menu to select the component. I want to look at ignition. I want to look at ignition primary. So I'm going to slide the cursor up to automotive and select ignition, and you can see that each selection brings another pop-up menu straight away. I want to look at primary. So I'm going to slide across to primary, and we have yet another pop-up menu, and it says primary, primary with current, primary ignition versus crank angle sensor, primary versus secondary, and primary voltage versus current. I just want primary. That's all I want is voltage. So I'm going to select the top, so slide across, select primary, and you now have the next hands-on help. Let's say that we're unfamiliar with what primary is, how to connect, where to connect, how to connect. Here we have a comprehensive guide. I'm just going to tab down slowly so you can see the actual amount of content of information, really to hold your hand to help you into this process of becoming confident with the scope. And you can see it explains probing. It then moves on to a sample of the waveform, what to expect from ignition primary. And the good thing with ignition primary is that all systems are virtually identical in its primary format. So you become very familiar with this. It then goes into detail about some of the functional components of that waveform. And this is absolutely vital. It's not just important that you show the waveform, but you actually understand the composition of it, because it's with that composition that you're going to find where the error is. And this software will help you do that. You can see it's very clearly identified. The sections are clearly described and detailed, and you can see it's quite comprehensive. We go tab down and explains all the functions of the induction and discharge of an ignition coil. Having digested the information, all we need to do now is simply minimize this page by dragging the cursor, and as you can see now, the scope is in the profile for ignition primary. Simply depress the spacebar and the scope will run. So first of all, let's begin by starting the vehicle. We're going to connect to the ignition primary circuit, and I've also, as a suggestion, put a sky hook up. It's very important that we look after the leads. The engine, of course, has rotating components and hot components, all of which are no-go areas for sensitive diagnostics. So I'm simply going to demonstrate the use of a sky hook, and we're then going to connect to the ignition coil primary. The two connections that I've ensured are correct: battery negative with the reference lead, and this type of vehicle has a double-ended coil principle, where a four-cylinder engine has two independent coils. We are in one coil winding only, so we're looking in effect at a pair of cylinders. Now, you press the space bar, and we now have an extremely accurate rendition of the waveform in one of those coil primaries. And from this signal we can now refer back to the help page and the text to interrogate and understand all the composite components of that image. And if you like, let's just perhaps display a simple fault. I'm going to just display a misfire. I'm going to do that simply by removing a plug lead and just creating an air gap across the plug, and we'll demonstrate how the burn time is this section here, will diminish, and that's quite important. As you can see from that very simple but effective demonstration, that during the process of just lifting the lead off the plug, by using an oscilloscope, you see very, very clearly that there's a defect in the duration of the burn time. And indeed, because the firing voltage, this section here, rises, it suggests that there's a high resistance in the ignition circuit. And of course, the help notes will identify that to support your conclusion. There we have a very simple test, made easy.